These are the slides that I used for the workshop. And I really like this slide because it kind of helped me to introduce the whole notion of creating a design space of options. So the shape I used for the workshop was very simple. It was just two rectangles here. The first base and height of the rectangle of this one were fixed. And then we were playing around with the base and height of the top rectangle, the angle of rotation, and the total height. So just to have like a quick example, I did three possible variations of each variable. So, for example, base 2 would vary between these three, height 2 as well, angles and height. So this will give us 81 options when you do the math. Essentially, what we're looking at here are four parameters that will build up our model. Having said that, we know that the first rectangle here is fixed, so we're only varying total height, angle, base, and height of the top rectangle. So we can see three possible combinations of each one of these variables. That when you do a cross product of all these options, you get 3 to the power of 4, which is 81 different configurations or generations of the same shape. That is essentially what I refer to as the design space. And this is pretty much the input for the generation of different options. And this is what I have here. If I run the cross product of my base 2, height 2, angle, and total height of the building, I will get 81 different generations, right? And if I think of my script as a function, essentially the parameter that's going in my function is just 4 variables, and the output would be a shape, right? And after I get the shape, I want to extract 3 numbers, which is building volume, the surface area of the facade, and the floor area after intersecting a lot of planes representing the floors. Once I get these values, I want to jump to the next generation and then do the same process and start looping everything until I finish with my last option. So to do that, what I first thought of was creating my design space. I tried to find a node in Grasshopper that would do the same thing as a Cartesian product. What I found was in Grasshopper, it's limited to 2 lists. So, for example, if we wanted to vary the height, angles, and other types of geometry here, we would need to use Dynamo to cross product all of those lists. But for this case, I just use two set of variables for the shape that I'm going to show you. I need to create a design space, which is just doing a cross product between scale factor of my top profile and the height. So that's why I used Dynamo right here. I have 2 of my variables, the height and the top scaling factor of my profile. And I'm going to make a design space between 3 iterations on each one of these. So I use a Cartesian product. Let me just run this real quick. The Cartesian product would give me the combination. And then I need to flatten this list a little bit just to extract the pairs. And then this is just to make it a little bit more interesting. I did a shuffle because I don't want to see the pattern. I don't want to be biased by the pattern. I just want random generations of these pairs. So I want to access this design space of 18 elements. I want to be able to get it from Rhino or Grasshopper. So what I did is I just exported here my design space. And I actually built 2. I did this one, changing just 2 parameters, total height of the building and the top factor, scaling factor. But here I have the same process, but for a more interesting design space. Here I'm changing the height, the angle of the mid profile, the scaling factor of my mid profile, the top angle of the profile, and the top scaling factor as well. So this list would give us a very big design space, which we can see here in Excel. I have 2 tabs here, the reduced space, which is just for this example. The first column is changing my total height. and this is the scaling factor. And the full space would have total height and scaling factors for mid and top, and angle for mid and top profile as well. But we're just going to use the reduced space for this example. And now I need to follow this process. My function, which would be Grasshopper, would call one row, and then it will use each one of these variables to produce my model and then extract the information. That's the overall process.